to Startuprad.io, your podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. This is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany, bringing you another episode in our cooperation with the European Enterprise Network and Hessen Trade Invest. But before we get to that, I would like to welcome my guest, Fabien. Hey, how you doing?
Nice to meet you, Joe, and thanks really a lot for inviting me today to speak about our exciting business with you.
Yes, we'll talk a lot about big things today. That is not a dirty joke. The very simple reason is you guys are inspecting large infrastructure pieces, think bridges, think high voltage lines and stuff like that. But before we get into all of that and what you've done before, a little word from our sponsor. This recording is supported by Hessen Trade and Invest and the Enterprise Europe Network Hessen. This recording was made possible by HTAI and the Enterprise Europe Network Hessen. These organizations have made tremendous contribution to helping startup businesses succeed and thrive, providing a range of services from helping to find grants to ongoing partnerships. By taking advantage of these resources, startup companies can network and develop innovative strategies for success on the international stage. The dedicated support of HTAI and the Enterprise Europe Network Hessen is paramount in providing startup businesses with the tools for lasting success. Look for our dedicated sub-podcast in partnership with them called Tech Startups Germany or on our link tree. Now we got this out of the way. Fabien, very happy to have you here. And we may tell our audience you are a software engineer by training, and you walk me through a little bit your life, what you did before you founded your current startup, Twinsity. Can you try to do that again? I found especially entertaining that you changed your employer without doing anything.
Yes, right. So, as you said, originally I'm a software engineer. I studied computer science here in Kassel in Germany. It's between Frankfurt and Hanover, and started working at the company from my dad, who co-founded a drone software company or drone hardware company as well, called iBotics. In 2010, I was working there as a software engineer, focusing on, let's say, flight planning software for drones, or for the drones that were built by iBotics. And stayed in that industry now with founding Twinsity, actually. In the meantime, I was at Fraunhofer Institute in Kassel working on renewable energy infrastructure. Especially I was focusing on virtual power plants, which is like connecting decentralized renewable energy plants to provide stability for the grid. But that's just, let's say, a different topic. And in 2019, I started founding Twinsity together with my father, and still being the software developer for this part, especially for the 3D development of high-resolution 3D models and the processing of data, actually, that is generated by drones. So we are staying in the industry, but concentrating more on the finding answers in the data that is captured by drones.
Mm-hmm. Before we get into the finding answers part, you've been a software engineer at iBotics, and that was the business of your dad, and then it was bought by Leica Geosystems, and basically that's how you changed your employer without ever leaving your current job, right?
Yeah, the company iBotics, as you mentioned, was acquired by Leica Geosystems, which is a subsidiary of Hexagon. It's quite a big player in the market for surveying equipment and now drones as well, and laser scanners and data, geospatial world data and so on. And they bought us, and so we, let's say, iBotics was still like an own company within this complex or within this subsidiary Leica Geosystems. So all developers were still at the company, still developing further. So the title changed, the company changed, but the job was the same.
And basically, we may already tease that your dad is also your co-founder in Twinsity as well.
Right. Yes, we founded the company together, kind of a family business in the beginning. Now it's not a family business anymore in the sense of that it's completely led by the family, but it's now maturing into a, let's say, more diverse startup.
Mm-hmm. There are not that many people who will actually watch this interview, but for those people who are watching this, we may tell them that you have pictures of high voltage lines and large windmills in the background. So that already sets the tone. That's some of the pieces of infrastructure we will be talking about pretty soon. Can you take us along the journey how you and your father actually founded Twinsity and how did you come up with the name? Because first thing everybody thinks, smart cities, huh?
Yeah, so we started founding the company after leaving the previous company, iBotics, which was sold like several years after it was sold. And in the time during the previous company, we recognized quite heavily the problem or the challenge of companies using drones that they don't really know what to do with the images being collected by the drone. So what comes next? Drones are just flying cameras producing thousands of images for one bridge, for example, but finding answers in these images, that's the challenge, the bottleneck, and that's still the bottleneck. So that was the reason why we decided to, let's say, investigate this problem and try to find a solution to that will analyze those huge amounts of images and generate high resolution 3D data out of that. So producing like a Google Earth version of the asset, but in much higher quality. That was the overall game at the beginning. So producing a digital twin, so to say, of an asset that is inspected by the drone. That was the major component that we developed as the first, let's say, starting point for Twinsity. So how we can create a digital twin out of the images.
Mm-hmm. And when you're talking about an asset, coming from the asset management background, not physical assets, but talking about bonds and funds and shares here, that is something different. We are always talking about structures when you talk about asset. Plus, it always implies that somebody owns it, and we can rightly assume the person or the entity who owns this asset is actually the one who is hiring you. And with you, it's not flying the drone around, but basically they drop you a lot of data.
Yes, right. So when we talk about asset, as you said, it's like about big infrastructure objects like a bridge, high voltage power lines, industrial facilities, oil and gas platforms, but also buildings. So everything that needs to be inspected on a periodic base, this can be, so to say, used with our platform. And you're right. Our major customers are the asset owners, and operators, these that are responsible for ensuring the safety, the reliability of the assets, that are interested in keeping them, let's say, alive and no need to turn them off, like for offshore platforms, for example, or for road closures, or even more catastrophic events. So these are the customers that we have. Those customers, like asset owners, already have drone programs in place. So they already utilize drones for capturing the data of their assets. And so they are using our software and providing us with the images they already collect. And so we are not a service provider. We don't own the drones. We don't fly the drones, but we deliver the operating system, the software side, for those asset owners that wants to get insights from the data they already collect.
And just to be sure, what do you actually get? Do you already get 3D images, or do you get just simple digital photos and videos and you have to do all the stuff with it?
Usually we get the images, like the data that is captured by the drones directly. So the raw data the drones capture. So this is especially RGB images, but also sometimes thermal data, like thermal images. but usually RGB for the visual inspection side. And we then can generate those 3D models on our own internally. So we only need images, and we create the 3D model, and we analyze the images for defects, basically.
And as we've been speaking before, what I had in mind, and many of our audience will have in mind, well, it's a bridge, it stands there, and that's it. But actually, you highlighted that there are quite some challenges for infrastructure, and not like the Romans who built bridges who are still up and running today. The bridges we have been constructing in the past have a planned lifespan of around 60 years, right?
Right, yeah, and they are built probably in the 60s and 70s, the majority of all bridges. So now they are more and more reaching the end of their design lifetime, which means that we now need to deploy more sophisticated and ensuring safety measures and repair works and maintenance activities to prolong the lifetime of the bridges compared to the design time. So it's really important that we strengthen them in order to reuse them or to still be able to use them over the next couple of years and even longer, rather than, let's say, creating or building new bridges, which is much more heavy when it comes to the natural resources, human resources, and so on and so forth.
Every commuter here in the Rhine-Main area can quite talk a lot about bridges being not maintained as much as they should be. What comes to mind is Schiersteiner Brücke, Selbstbachtalbrücke. There have been two really big obstacles where people needed to drive around for like 30 minutes additional one way or stuff like that. That wasn't fun and was all the rage here in the Rhine-Main area for quite some time, because first one bridge was closed and rebuilt and there was one rebuilt just next to it, and then another one on the same way to Frankfurt was closed for some time. They actually had an inspection truck, and the inspection truck data was so severe they had to lock down the bridge and then had to take a lift and lift this truck off the bridge because it was not safe enough for the truck to continue. So there are some challenges out there. When we talked before, you said there is a life expectancy of those infrastructures. How long, for example, would something like a high voltage line last, or as you said, like a oil drilling rig or something like this? Do you have any idea about those assets?
That's really depending on the type of assets, because like a power voltage tower or like utility tower can be made of steel, of concrete, or of wood. So it's really depending on the material being used as well as the weather conditions at the site. So, for example, in California, there will be different weather situations compared to what we have in Europe, for example, in Germany or in Scandinavia. So we can't really talk about the expected lifetime of those assets, let's say, defining a clear number of years. But for these kind of assets, it's much more important to still know exactly about this, the condition of the assets, because of these weather situations that are quite severe. And so the assets like the power poles will deteriorate and will be more affected to those weather situations, which means there can be a lot of damages and potential defects that will be quite critical to those assets in order to it needs to be, which means that those assets might need to be replaced or even can collapse, which will turn off the overall utility, so to say, in that region. So it's really important that we know about the condition up front in order to maintain those power poles, for example, or even like oil and gas refineries, offshore platforms. So it's not just about the time, let's say how long or what's the expected lifetime from the beginning on, from the design time, but it's just really important in now over the next years to really know exactly about the condition.
I see. Before we get into a little bit more what you guys are doing and about the drones, what I found fascinating is he told me how those high voltage lines are actually have been inspected in the past. That means somebody rented a helicopter and you put like half a dozen engineers in this helicopter and they flew along those high voltage power lines, which I assume was quite pricey, even though what I had in mind was something like an open door in a helicopter, somebody tied to the helicopter with all this gear, and then looking out with the binoculars onto the different high voltage poles. Would there something close to realistic that happened in the past?
I mean, that's exactly how it works right now, and not just in the past. That's still how many companies do the inspection activities, um, because I mean, that's still the safest way to do it, compared to needing scaffolding or some climbers that will climb on the tower. It's still better to do it, let's say, not directly at the tower, but with a bit of distance. But it's quite expensive to hire or to rent helicopters to do the job. It's quite expensive to have 6 or, like you said, different engineers sitting in the helicopter. And I mean, with an helicopter, you can't do that many different power poles per day because you really need to be far near to the power pole, and still can't get to the maximum detail, so to say, that you probably would need to do. So that's where the drones get in to automate this process to capture the data.
Before we get into that, just one question to confirm. There are people whose job it is to climb on high voltage poles?
Again, this is not the favorable way. This
Yeah,
is
but for repairs or something like that.
Yeah, that's definitely happening. Yeah.
I'm curious if those guys get life insurance anywhere. Anyway, sorry, got a little bit off the topic here. So that means people are flying drones. They're likely a little bit bigger than your average drone you have at home, and they capture a lot of pictures, which means it's cheaper. Does it also mean your clients provide you more frequently with update, with pictures, with video, with infrared recordings to put in your database to maintain the digital twin in your database of the asset?
Absolutely. That's the beauty about the drones. They capture the data autonomously. That means you don't need a pilot anymore. I mean, that's changing quite a lot now, that drones will really capture the data automatically with a predefined route without any pilot being involved anymore. So we always get the same number of pictures for the same route. And so this route can be done every day, every week, every month, every 3 months, depending on what the customer wants or what the asset owner is relying on, what they want to do. So for us, it doesn't matter if it's a weekly base, a daily base, a monthly base, but still it's in every case, it's much higher frequency compared to hiring a helicopter that does it every 2 years once, so to say, or one time every 2 years. So, with drones, you get really to much more frequent, inspections.
Mm-hmm. I see. And now comes the magic part. What are you guys actually doing with all those pictures, videos, infrared recordings, and so on and so forth? Personally, I would assume you have very capable AIs who then extract the necessary data from it. You have a big database where you put all of this in, and then you do have a digital twin in your database, where you would, I think, share again the data with the asset owner, with the client.
Well, that was a really good summary of our product or of our software. So basically, there are two different components involved in the process. That is, as you said, it's completely correct. It's a digital twin. That's one of the proprietary technologies that we developed over the years, to take all the data from the drones, from the asset owners, and produce a high resolution 3D model of the object to be inspected, like of the overall bridge, or of 10,000 of power poles, or of the overall offshore oil platform. So we just take the data and create this high resolution 3D digital twin out of that. And this digital twin can be visualized on any device with our web platform. So you can use it on a tablet. The engineer can use it on a smartphone, on a laptop in the office. No matter where you are, it's streamed over the web into your web browser, so to say. So our software is a cloud-based software solution. The second part, as you mentioned, is the AI to autonomously detect defects and issues upfront in the data. So what this means is we take all the images and our AI runs over that to detect, like, for example, on bridges, cracks or rust. That's just two examples of many different defect types. So the software runs over all images, detects cracks, and so the engineers of the asset owners will eventually get a list of all cracks we found. And so they can review crack by crack and give us feedback about if this really is a crack or if it's not a crack. So with every inspection we do, or our customers do within the platform, our software gets better and better, because we always ingest the data back into the training of the AI.
Talking about cracks in bridges here, how big or how small can they be in order to be detected by your software? And admittedly, of course, a lot is dependent on the quality of pictures you get delivered from the drones.
So actually, there's no limitation in the size. So the bigger, the better for our software to detect, obviously.
That will be a takeout for Christmas. Okay, the bigger bigger the better the cracks. Fabien, there you go.
Yeah, but I mean, in let's say in general, the cracks can be up to 1 millimeter in size. So that's maybe the lower limit, which are the more relevant cracks to detect actually. For the software, because bigger cracks will be detected even without the software. You can already see it when you have a look at the bridge being on site. So it's important that we especially support those small cracks, 1 millimeter in width, for example, that the human eye can't see when you be on site. So that's really crucial that we recognize or that we detect those issues, and we can. So up to 1 millimeter, as I said.
We do already have a pretty good understanding of what you guys doing, where you guys going. I do have a few questions for you on what you'll be doing in the future. We've been talking about such a lot of about structures and assets. Is there one you would like to inspect with your software? What comes to mind are really iconic items like the Statue of Liberty, the Hoover Dam, the Eiffel Tower, the Brandenburg Gate.
So the Eiffel Tower would be really, really interesting because it's quite a big steel structure that is not really easy to model or to process as a 3D model. Because it's that, I mean, it's like a really big power pole actually, or like a huge transmission tower. But that size of an object would be really challenging, and thus it would be really interesting for me to see how the software is capable of doing exactly this kind of structure.
Mm-hmm. So the Eiffel Tower it is. We do have a lot of our audience in Europe, but also something like, I don't know, 50,000 listeners a month in the US and abroad. Where are you guys available? And is there like a real limit to where the structure, the asset could be?
So right now we are quite focusing on Europe, so especially on Scandinavia, on Netherlands, on Germany, and the overall DACH region, but also now heading a bit into Southern Europe. And over the year, we are looking into scaling into the US or North America and also Latin America, as well. So we are about to open an office over there in the next couple of months, hiring some people over there. And in the end, it doesn't matter where the asset is. There are quite similar defects. A bridge in US looks quite the same like a bridge in Europe. So there will be also cracks, rust, spawning, different defect types on bridges, as well as the power poles are also made of wood, steel, or concrete. So that's quite comparable to Europe. So from a software perspective, it doesn't matter where the asset is.
I see. And when you talked about Scandinavia, what came to mind is the very severe weather there. There could be some places where it gets minus 40 degrees Celsius. No idea what this is in Fahrenheit, but it's freaking cold. And you have high voltage lines and stuff like this there, bridges. Plus, when you talked about the Netherlands, what came into mind are all the dam structures there. For everybody who's not familiar with the country, it's called the Netherlands because a large share of this country is reclaimed from the ocean, and the actual level is already under the normal sea level. So they have to work with a lot of dams, a lot of dewatering facilities in order to keep their country alive. Is that something you're working on?
For sure. So for bridges in Scandinavia, or let's say for bridges in Scandinavia, we are quite heavily working with engineering companies over there that are giving us the expertise on specific damage types, like that are really known for Scandinavia, but they're not happening in the rest of the world, for example, or that are really specific for those regions. So that's exactly what we have in mind with our platform to be agnostic in the sense that companies in Scandinavia can retrain our platform for their specific defects without us being involved into that process. So their experts know exactly about the problems they have in Scandinavia, but we don't. But they know exactly, so they can retrain our platform to be capable of detecting those issues as well. So Scandinavian version of the platform, so to say. Scandinavian bridge version of our software. That's what we have in mind to develop. So to be that open and adaptive platform where our customers can specify what they want to detect, and the platform adaptively gets better for their specific problems.
I see. And before we get into that, minus 40 degrees Fahrenheit are minus 40 degrees Celsius. So everywhere it's freaking cold. Um, that said, I do believe if you have your AI trained for Scandinavia with all the severe weather out there, specific defects on bridges and so on and so forth, maybe other countries like Canada would also profit from that. Talking about all those options for international expansions, are you guys actually open to talk to new investors?
Yes, we are actively raising our funding right now, which shall be done until end of Q2 this year.
Mm-hmm. I see. And you guys are also looking for talented people to join you?
Absolutely. We are looking into expanding our team right now. As I said, one part is US office and US expansion, but on the same side, we're looking for really great software engineers in the cloud architecture and computer vision departments, as well as great business development managers and salespeople for scaling our business in Europe.
Are there mostly remote or all remote positions included?
We are a remote first company, so we are looking especially for remote jobs. We have a office facility here in Kassel, but our team is quite spread around Europe and US already.
Mm-hmm. I see. For everybody who'd like to learn more, you can go down here in the show notes. There will be a link to Fabien's LinkedIn profile, as well as the company website, as well as your careers website. And since this is in cooperation with Hessen Trade and Invest and the Enterprise Europe network here, there is your option to address the decision makers here in the state of Hessen. Ideas, concerns, things they could improve. Do you have anything to address here or questions to ask?
So, as you know, we are based in Kassel, which is quite in the nowhere of Hessen. compared to Frankfurt, which is the central hub, and Darmstadt and Wiesbaden and probably other cities that are more known to be startup friendly. I mean, Kassel is trying to do things for startups, but I think there's a lot of potential to optimize the landscape for startups. Just one example is it's quite, I wouldn't say impossible, but it's really challenging to get an office here in Kassel for a startup. You have some like a campus, or you have like a building for some startups, but this is not really, let's say, open to everybody. It's really close to the university. And so I think the ecosystem for university spin-offs is quite good in Kassel already, or in Hessen, especially in Kassel. But for other startups, I think the ecosystem can be more, I mean, it can be broader. It can be more supportive for the startups with the right, maybe, mentorships, but also something, quite easy, like an office building where you can now finally start building your company. I think that's what still is, let's say, to be optimized.
I see. So, Fabien, it was a pleasure talking to you. Thank you very much. Good luck for your expansion plans, and when you successfully launched in the US, we will report about it again.
Thank you very much, Joe, for inviting me again. It was a pleasure talking to you. I think, I liked it a lot and appreciate that. So let's speak again once we are in US.
Sure. My pleasure. Have a good day. Bye-bye.
Bye-bye.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.